But if you think about machine learning and stepping back, it's all about the prediction. So essentially, you have the black box model. You don't actually know the inner working, and you are trying to map your input X variable into output, and you don't really care about what's going on inside. That's essentially what machine learning is all about. It's actually, if you think about large neural network, you don't really know, what's going inside. But there are actually problems with this approach. It's one thing to predict well many business questions. You don't actually care about the prediction at all. You care about if I do X, what's going to happen with my Y. Right? You're actually interested in measurement problem, which is if I make X changes, some changes in X, delta X, what would be a change in Y, delta Y? That's completely different problem than machine learning. You're actually doing X to Y mapping, but in causal inference, your problem is actually delta X impact on delta Y. So it's actually a fundamentally different problem. So you need some counterfactuals or the simulated world, which is not observed. Usually, unless you do A/B testing, you actually can see both sides. But that's usually not happening in actual most of the time.
Hey everyone, welcome back to the Ignite podcast. Today we're thrilled to have Minha Hwang on the program. He's a principal applied scientist at Microsoft, which means he's pretty senior. Minha has been a leader in AI experimentation and statistical analysis at scale. His work focuses on topics like causal inference, A/B testing, and model evaluation in high-stakes machine learning systems. He's also passionate about translating cutting-edge research into practical, measurable improvements, especially in the fast evolving world of large language models and AI-driven experimentation. Thanks for coming on, Minha.
Yeah, thank you for inviting me.
Yeah, I love doing these. We're typically like a startup venture capital podcast, but I called it the Ignite podcast so we could have anybody on and talk about anything we want. So including AI. So you've built a career around data science, experimentation, and AI. What first pulled you into this field?
So I'm engineer by nature, always try to use the data for any decision making, right? So I studied as an engineer at MIT. So I actually did material science and engineering as my first PhD. So use the numerical simulation and optimization to design nanostructured magnetic material for data storage. So maybe data was even already there, the storage for the data. Right? But after I got my first PhD, I realized that being an engineer, it might be too narrow. I want to see the broad world, right? So I joined McKinsey and Company as a management consultant at the time, and it was actually fun. You get to see beyond R&D or engineering, so entire business, like different functions and different industry. So I did it for about 4 years. But being an engineer in my nature, I realized that I can do the generalist, I can be broad, but I enjoy more when I actually go deep about certain kind of specialty, especially around the data-driven decision making. So I did quite many credit scoring study in consulting company. I found it very interesting. You get to use statistics and data science to actually guide the decision about who to give a loan, as example, a credit card. So at the time, there was no data science, but I felt that this is actually a kind of thing that I want to specialize in. So I was looking for the data science opportunity. Obviously, at the time, there was nothing available in the industry before data science. But I realized that there are actually special niche in the business school. There are PhD program in management science or marketing science. So because of that, decided to go back to school again. It was really crazy. I did only first PhD and then have 4 years of career. So it's pretty rare to people to go back to the school, especially for second PhD. But that's what I did. And I got the PhD in marketing science. So essentially that's the marketing data science before the data science, right?
Oh.
So I was brainwashed along the way, naturally become the marketing professor in business school. So I taught like marketing research or marketing science. So I was teaching at McGill University for about 4 years and a half, but I was a little bit spoiled in California. I missed warm weather, nice weather. And also after spending 4 years and a half as a academic, I realized that I actually want to apply my research into actual. So then maybe me come back to US. So this time San Francisco, I knew that this is actually the hub of the AI, machine learning, or data science. Also at the time, actually, interestingly, there are big data booms, right? So data science now become a big deal. And my former employer, McKinsey, is actually building the data science arm. So they started data science consulting. They're also introducing SaaS solution on marketing science, like the pricing solution or the promotion planning solution certain optimization solution, which is highly aligned with my research. So I decided to actually apply my research through this opportunity as a almost founding member of this new division. It was pretty fun. It's like new venture with the large company. So I get to build a lot of new things. I built an algorithm behind this SaaS solution. So spent about 6 months, 6 years and 7 months in that company from 2014 and 2021. But after I initial building kind of phase passed, they are kind of mature. Also, I was now become more interested in the non-structured, unstructured data part of the data science, which is like text, image, speech kind of thing. So decided to actually venture into this space. So search engines obviously most obvious application of the NLP or unstructured data. So decided to actually do this. So I moved to Microsoft back in August 2021.
We overlapped because I left in 23. I was on the Azure Marketplace team, and then I was over on content services, working on ranking and personalization on feeds,
cool.
particularly for MSN Money, which I
see.
which I helped rebuild before I left.
Yeah, MSN is our sister team almost. We are like search engine. MSN is obviously highly related to Bing.
So you've been there for 4 years. How has your role as an applied scientist evolved during that time?
So I started with the focusing more on the like A/B testing side. The key problem we had was there are a certain goal metric, like you can think this as an engagement metric for the consumer. So that's a highly important metric to move. It become a goal for the entire organization. But it's very hard to move. People need more sensitive metric, which is highly aligned with this goal metric, so-called proxy metric, or you can think about any other ways to make the A/B testing more sensitive to squeeze more from the limited traffic, right? So those are my initial kind of projects. So I explored how to use machine learning to squeeze more from the limited traffic. So one way to do it is actually reducing the variance, reducing noise of the experiment. So I come up with a way to use machine learning to reduce the variance and noise. So that's one of the project I possibly did. And also another one is so-called surrogate or proxymetric development that is more sensitive than the key goal metric, but directionally highly aligned, right? So those are kind of my starting point for the initial project that was solving one of the key problem our A/B testing had, sensitivity problem, you will. And after that, it's kind of moving into other kind of method, which is beyond the A/B testing. So there are actually other methods you can use instead of the A/B testing, like multi-armed bandit or interleaving techniques, explore those different methods which are applicability. Around like 2023, you know that the ChatGPT moment and AI or large language model become a big deal. Obviously, our focus also shifted a little bit, right? So we are now thinking about how to measure the LLM application, their impact on users. Naturally, they change into that space. So it was pretty fun, new problem, how to evaluate the AI. So that was for past 2 years. So beyond that, sometimes you cannot really measure the overall impact by using this A/B testing or offline metrics. Then you need to think about what else can be done based on the typical log or the byproduct of the business, right? So that's called the observational causal inference. So I also do some of those. And sometimes if there are other teams having some problems, then I do scientific advisory for those teams to actually figure out what method can be used. So those are kind of broadly my three roles. So A/B testing and online testing and LLM or AI evaluation, especially in terms of the preference alignment or preference measurement. And finally, by using the observational data, how to do causal inference to measure causal impact of certain product features or some marketing campaigns.
Yeah, I love that. So you've posted a lot about false positives being shockingly common in real world experiments. What causes these and how can teams avoid them? And maybe you could just take it at 100 level, assume our audience doesn't even know what a false positive is.
Yeah, so one reason for this is, right, we are doing a lot of experiments, right? So if you are doing a lot of experiments, like even by the random chance, sometimes you see some effect, right? It's not really true effect, but because there are noise in the experiment, if you are doing like 1,000 times, you get to see like actual statistic result, even though there are no effects, right? So that's kind of what's going on. It gets worse if you actually are using multiple metrics. There are so-called multiple comparison problem, multiple hypothesis testing. So it actually make it worse. So there are multiple reasons why you are having this problem. Also, if you are using the not enough traffic, so-called underpowered experiment, also it's more likely to have this problem. Mainly because we are doing a lot of experiment, so even by the random chance, you can actually see the false positive. And also, if you're not assigning the traffic properly, then it's also more likely to see false positive, right? So there are some statistical ways to actually kind of tell whether it's more likely false positive. Also, there are practical ways to actually tell whether this is real impact or false positive. One good example is that you run one experiment and you find that there are some impact for your key metrics, right? But if you are really unsure, one good intuitive way to do it is run the second experiment to make sure that this gain in the initial experiment is actually reproduced, right? That's one way to actually confirm, very intuitive. So we call this as a solidification. So if you are not sure, you can actually run the second flight to actually make sure that it's actually real impact. Many times, actually, it doesn't go through that gate. So then we can actually tell, no, first was the lucky.
So you recently highlighted LLM quantization work. What makes this line of research so significant in this area?
So as you may know, now large language models getting bigger and bigger. It actually gaining the capability with the large number of parameters, so-called scaling law, right? But as a downside, it actually requires more memory, more computation. So one way to actually reduce the problem or solving the problem is how to make this overall model smaller. Even at the same time, we are maintaining number of parameters. There are techniques like quantization or some compression method actually allow to squeeze more from the limited memory, right? So this can also allow you to put really large model into smaller devices. Like you don't need data centers to run this model. As an example, maybe in the future, you might be able to put this pretty capable model into your edge device like laptop or even smartphone, right? That will enable a lot of possibilities, right? That's the reason that I'm interested in this space. And also it's amazing that there are a lot of progress in this space.
So what are some of the most promising methods to reduce the size of these models? Like I've heard, you can reduce the floating point. What are some other ways?
Yeah, the obvious direction is basically reducing the floating point, number of bits you use for the model from 16-bit to 8-bit to 4-bit, or even make it dynamic. So that's obviously one direction, right? So yeah, so quantization by using the bit reduction is the most prominent way of actually achieving this. But there are other research going on. Some interesting ideas try to define the block and then you actually assign some seed, and then by using pseudo-random number, you can actually reduce this down to some seed plus some dynamic coefficient you can multiply to, like in the idea of in-person sampling. So that is also an interesting idea to actually do this. Also, there are others more like the matrix kind of idea to actually do this with different way. So there are many active research going on. So it's actually interesting space to look at.
In your view, how should teams balance statistical rigor with iteration speed when deploying ML models?
Yeah, that's a good question. So there are always balance between the actual business impact or the user experience compared with the scientific rigor, right? So sometimes you have to make a trade-off, almost like the ROI question, right? So if the small improvement in model is actually worthwhile to actually do. So that actually enforces you to have continuous kind of cycle. So once you fine-tune or develop model, you have to do evaluation and measurement. And then after you find out, no, it's enough or you need to keep going, then you have to go back to the model, decide to launch, and then maybe actually see the actual model application impact on user from the field deployment. So that's the decision you need to continuously make. So if you can make this iteration cycle fast, you have a lot of advantage. So it's all about how to actually cycle through this faster. And the real bottleneck is not model training. I mean, it's also difficult for sure, but the real bottleneck is actually data, because once you evaluate the model and then it's not satisfactory, you usually have to go back to the data. That's most of the cases, right? And the data generation or data collection is pretty time consuming, especially if you need to collect the human labels, right? So that's actually the majority data set in post training of the model, because you want to align the model response to human preference, and that's it's mostly coming from the human labels. So that's actually time consuming part. Fine tuning of model takes some time, but post training usually take much less time compared to pre training, which is a couple of months. So post training can be a couple of days or just 1 week or 2 weeks, right? And evaluation is another kind of important area. With the large language model, what's happening is that now the emphasis or the importance is shifting from the training to data and evaluation. That's kind of the change I see from the traditional machine learning compared with the new generative AI or large language model.
So, how do you think about causal inference? And maybe you can define it for the audience and how it's
Mhm.
evolving in a world increasingly shaped by generative AI.
Yeah, this is actually quite interesting one. So a lot of people consider machine learning as a really the foundation technology. But if you think about machine learning and stepping back, it's all about the prediction. So essentially, you have the black box model. You don't actually know the inner working, and you are trying to map your input X variable into output, and you don't really care about what's going on inside. That's essentially what machine learning is all about. It's actually, if you think about large neural network, you don't really know, what's going inside. But there are actually problem with this approach. It's one thing to predict well. Many business questions, you don't actually care about the prediction at all. You care about if I do X, what's gonna happen with my Y. You're actually interested in measurement problem, which is if I make X changes, change some changes in X, delta X, what would be a change in Y, delta Y? That's completely different problem than machine learning. You're actually doing X to Y mapping, but in causal inference, your problem is actually delta X impact on delta Y. So it's actually a fundamentally different problem. So you need some counterfactuals or the simulated world, which is not observed. Usually, unless you do A/B testing, you actually can see both sides. But that's usually not happening in actual most of the time. So you somehow have to think about how to make this counterfactual simulation or missing kind of observation as a base, and then compare the actual to get the incremental effect. That's actually hugely important effect, even for Google's business or the search engines in general. You essentially try to measure impact of advertising. So that your base will be if you're turning off the advertising, what's going to happen to your sales. But you actually have the advertising, then you cannot attribute all the sales to advertising. That's nonsense, right? You have to compare what the base state we don't actually see, but what kind of sales do you gonna generate if you actually turn for your advertising. So that's a good example. Same thing applies to your price promotion. If you are running the promotion, obviously you have more sales, but even without the promotion, you're gonna have some sales. Then the question is, what is the baseline? What is the counterfactual? So this applies to almost all business problems. Unfortunately, this is highly important, but not really taught well in the master programming data science. They tend to focus more on the predictions. So I think there are imbalance about supply and demand. There are a lot of demand about causal inference in the industry, but unfortunately, there are lack of supply from the academia.
So, you've curated a lot of resources on reinforcement learning. What excites you about its potential right now?
Yeah, so that's actually UI area. So one way to get the data is UI. So far, we are focusing on so-called human labeled data. So that was actually the reason that large language model is doing so well. They have basically collected all the data, human generate data from the internet, and then really training all really big models, right? But right now, it's actually a lot of the discussion going on about whether we want to have enough data going forward with the really large language model. So we are consuming entirely, almost all the data on the internet. But there are some research kind of argue that between 2026 and 2032, maybe you cannot really get more data to train a model, right? So that will limit your capability to make a better model. Also conceptually, also in real region, if you're using the human generated data, the kind of model you make will be limited by the human intelligence, right? Because you are essentially trying to reduce the gap between your model and the human as a benchmark, right? So if you want to make some super intelligent kind of model, and not for general sense, but at least for certain domain, then you need to have different way to do it. One way to actually do this like active learning kind of approach. So you learn the agent, a model to actually do some experience, some interactions, and they are basically doing learning by doing. This interaction actually works well, so I should keep doing this. Well, this one doesn't work so well, so I should not. It should reduce this kind of action. So that's essentially reinforcement learning. The agent is interacting with the world. They are getting the signal as a reward, and then they modify the actions, right? So that is another way of the learning. So that actually give more signal than pre-collected data.
So, let's talk about what's kind of happening right now. DeepSeek is gaining ground. What should foundational model players be thinking about?
Yeah, so many people consider this as China versus US problem, but I think this is actually a different way to look at this problem. It's actually more open source kind of model compared to closed system kind of model. So what this actually opened up was that it actually allow many people to access the strong reasoning model through the open source. To be precise, open weight. They didn't actually release their training code and data. They only released the inference code and then weight of the model. Still, it's a big deal, but it's not truly open. Really, truly open model is only from the Allen Institute for AI. They actually have a Tulu model that's truly open source. For reasoning model, DeepSeek is the only kind of open weight model. Llama is another one, but DeepSeek is basically first reasoning model which become the open source. So this actually give a lot of the opportunity to study this kind of model, which wasn't really shared behind the scene of these like leading research labs. So this actually really reduced the gap between the open source community and then closed system leading labs. Right? I
Yeah.
think that's actually a more important aspect. And China versus US is maybe the secondary consideration.
How do you think about who wins in the long term? I mean, historically, it's been open source in AI, but do you feel like this time it's different and maybe closed source systems will win? Or do you think open source closes the gap and eventually overtakes it because you just have just more people working on the training and inference and of building these models?
Yeah, it's an interesting question, and no one cannot predict the future, But if I need to bet, I would actually bet for the open source community because it's very hard to actually compete against a lot of community. They have smart people. They have like tens of thousands of people working on and contributing this problem. In contrast, the leading closed labs, they may have 3,000 or 5,000 and most, right? They are very smart. They are maybe leading edge researchers, but still, they are limited by the human resources they can actually use. Also, with a lot of open source community contributing to certain ideas, if you have diverse kind of thinking, it tends to have more innovations, right? So if I have to bet, I would actually bet for the open source community eventually coming up with something which is comparable or even better compared to current frontier models from the closed labs.
Speaking of which, I mean, OpenAI is cracking down on output copying, a sign of what's to come. Recent reports suggest that DeepSeek's output mimics OpenAI to a suspicious degree. If you ask who made it, it responds OpenAI. So now OpenAI is tightening their access to APIs. What's your take on the IP and data integrity concerns around foundation model outputs?
Yeah, that's kind of contentious kind of topic, you will, right? So obviously, people are copying from the API for sure. The first one, which really make this well known, was the Stanford paper called Alpaca. They use the API service and they collect a high quality small data set and then show that that's enough to actually really crank up the model performance from the small model, right? So after that, this idea has been adopted for pretty much almost anyone. So you can maybe think that this is actually bad practice. Essentially, you are stealing IP or stealing data from the leading players, right? So that could be one kind of perspective. But what's making this more complicated is that even those like the frontier model providers or the research labs, they are not also free from the fact that they are also ignoring the IP for their underlying data, right? It's very gray what they use. There are some evidence that they might have used a lot of the IPs without getting the consent. So it makes it harder to actually tell who is more to be blamed. So it's a tough question to answer.
Yeah. So thinking about the future of real-time AI product or infrastructure between, GPT and Novasonic, that's Amazon's new model, it's clear real-time multimodal capabilities are kind of the next frontier. Will this change how we architect products or build infrastructure to support them?
Yeah, so multimodal is obviously one kind of direction because there are more than language that we are using as our sensory kind of the way to get the signal from the outside world. So vision is obviously one way, and there are more and more speech and other mode of the signals will be becoming more important, right? Because that will also require the input side of the model will change. So they will be more multimodal in terms of input side. And even for the output, people might expect more on the output side. So image generation is super popular with the recent update for the GPT-4 image generation as example. Also, there are a lot of applications for video generation, image generation, speech generation. So that will be a bigger deal going forward. Obviously, text generation is kind of the table stake, but people expect more and more, and it's going beyond that now. You can actually, for robotics as an example, you might expect vision to action. So it actually go beyond these like image, video, and text. Actually, you're thinking more about physical actions, right? So there will be physical AI kind of application, especially around the robotics. That might be bigger than the digital kind of AI application focusing on text now. So that will require different kind of inference or training. So one big difference is that LLM has been successful because we have a lot of the human label data on the internet, and they use so-called self-supervised learning. So they are predicting the next token. So in a way, you don't have to label the data. That was actually one of the secret sauce for the successful large language model. With robotics, it's actually hard to do. We actually need to have some good action demonstration, which is actually not available in large scale. So for those kind of applications, the simulated world will be more important. So there are a lot of effort going on to generate data from the simulation, which is close to reality, and then using that data to train this kind of models. So I think that will be an important area and which will enable many of the physical kind of AI.
What do you think about? Did you read the situational awareness paper by Leopold from OpenAI? You're familiar with this paper. What do you think about that? Like, yeah, as he's looking at these orders of magnitude, more compute and algorithmic efficiency, where do you think that? Where do we top out? Do we blow past AGI? Are we at AGI yet? And do we get to SGI in the next 5 or 10 years? Like if you're kind of looking at this, is there limits to scale here?
Yeah, this is very delicate topic, so I wouldn't actually, go into the debate. I think essentially there are two camps of the opinions. So one of them is kind of scaling camp, meaning that capability will get better and better with just scaling the data and scaling the model. So eventually you're going to have super capable model. In a way, so past trajectory is kind of with the trajectory, so there might be reason for them to kind of believe this direction. But there are another camps. I think that the one example is like the one of the leading researcher, Jan LeCun. He is actually suggesting that you need different architecture, different kind of models to really go beyond the limit of the LLM. So as an example, what he is suggesting is that LLM doesn't have the planning capability. There are reasoning models, but the counterfactual planning, the way to actually simulate the state is not in the data, is actually not there. Also, memory is another problem. So if you think about the human brain, there are a lot of parts maybe LLM doesn't have yet. So that's actually his point made. Also, in terms of data, the visionary signal is actually much more compared to language. So he's comparing the magnitude of data or information you are getting from the language versus vision or other means of the signals, right? So that also makes some differences.
Yeah, I mean, I think some people would say that even if we stop scaling at this point, if we layer in chain of thought and reasoning steps, we're basically at AGI already. I mean, you've seen the benchmarks on O3 and basically PhD level across dozens of domains. Now it's almost like even if we don't get smarter model, we just now if we just implement the ones we have, it can already disrupt our economy to a really big degree.
Yes and no, though. I mean, this benchmark, in a way, kind of designed in certain way. So even though you don't actually have data for the benchmark, one way to actually build this benchmark is that you are generating a lot of training data which is similar enough to the benchmark data, then you can do really well. It's in a way, it's overfitting, right? So you should just take the benchmark as a face value. So that's actually one limitation for the benchmarks, right? So there are
There
always
is the
debate
benchmark
of
where they hold it back, right? And it's kind of a secret.
yeah, but you can extrapolate from the similar data. That's actually a trick, right? So if you are really, intentional, actually, not it's possible to actually circumvent the benchmark or the holdout data and then do pretty well.
Now you could argue that most of what humans do is regurgitate knowledge, right? Like we hear things and then we regurgitate it and we kind of combine ideas, and with chain of thought and reasoning on O3, it's just doing that. It's mashing together ideas and regurgitating thoughts.
Yeah, that's one way to view it, but also there are other benchmark which is actually turned out to be very difficult for even the frontier models to actually beat. One of the top benchmark for the math, even the reading model only like achieved 23% and 3%. So, it depending on what kind of the standard you apply, that's also depending on your view about the capability, right? But one thing though is that practically it's useful, that's for sure. That can actually help with the code generation, or even the data science agent. You can actually automate many of the manual part, repetitive part, because essentially this is like zipped version of the internet. lossy compression. So if you have the smart retrieval by the conversational user interface, that's practically useful enough. You can actually do a lot of things based on this. But I think the debate about AGI is actually not meaningful. It's more about what you can do with this, whether it's useful for your certain application business. That's what matters at the end. And frankly, personally, I don't really care too much about AGI or whatever, because it's classical debate. But as an engineer, if it's practically useful, that's what matters. And sometimes it doesn't work. Actually, that's what matters to me.
Yeah, I love that. Well, let's wrap up with a rapid fire. What's the most underrated metric in an A/B test?
Maybe sample mismatch ratio, because you need to have good quality data to start the A/B testing evaluation. But if your data quality is bad, then SLM is happening, then you should not even examine the scorecard to begin with, right? But sometimes the software engineers not so experienced with the A/B testing, then they kind of were trying to analyze this even though the data quality is bad. So that's actually one problem. So another one is actually so-called debugging metric. So it's one thing to know that there are something going on in the A/B test. We are gaining something or losing something, but it's also important to understand why. Then you need another set of metric which help you to go deeper and then finding out why. So that actually is the harder kind of metric to build. So it's not enough to build your key metric or goal metric. You also need to think about how to debug, how to go deep.
What's your favorite paper in the last year you think everyone in AI should read?
Interesting question. Recently, I saw a paper from the Silver and Sutton, the reinforcement learning kind of innovators. So they actually wrote a paper about the era of experience, which is essentially suggesting that beyond human level data, you need the data from the interaction with the world or experience, right? Believe in that direction. Obviously, there are a lot of technical challenges, to be fair. It's not like it's going to happen automatically, but I believe that's actually the proper direction to go.
What's your go-to tool for library for experimentation pipelines?
That's an interesting question. So a lot of the large companies actually do have the internal system because it's complex enough for them to really customize. So it's not possible to outsource to third party, right? So that's basically kind of limit of what you can use. But if you're a small enough company, then maybe you can consider the third party kind of solution because you don't have scale to actually build this aspect. But for the offline aspect, actually, you have some flexibility because it's small enough for you to actually use some creativity because you can get by with much smaller sample size, right? So that's the area that I actually have a lot of interesting creativity can be used. So my background is marketing science. Actually, we study preference measurement a lot. So there are cool technique you can actually use about human preference measurement, which can be applied to offline metrics, right? So one kind of my favorite is actually how to measure human utilities or preference by using some experimental design of the preference measurement. So this is called discrete choice model of consumer preference. So this actually is invented by the Daniel McFadden.
What's one emerging AI concept you're most skeptical about?
Interesting question. Yeah, this can be debatable, but I would say the multi-agent, there are a lot of hope for the agentic framework. I do believe there are potential for agent framework. There are huge deal you can do about automation, especially with the conversational user interface, right? So as a good example, text to SQL will be allowing many people who do not know the SQL to access the data, right? But that said, this multi-agent kind of framework, I think that will be very hard to productionize. So there are a lot of the nice demo, but if you think about fundamentals of models, this will be very difficult to do. Recently, there are some experiments from the Carnegie Mellon University. So they set up the artificial simulated software company and then basically do multi-agent experiment. And even the frontier model only succeed 23% of tasks. So that kind of show the challenge of the having multi-agents kind of system. Building some practical application beyond LLM actually. I think LLM application is kind of too many companies are working there, right? It's little saturated. So I'm thinking non-LLM based application where you can actually apply decision intelligence. By my personal view, actually that's the larger business opportunity. So it's one thing to have technology, but you actually have to have technologies to solve, right? That can be the pricing question I just mentioned, right? So how can you make the automated pricing agent? Right now, it's highly manual process. So if you can actually make the pricing agent, which can help their decision, and then self-learning over time by doing the selected experiment that can be very powerful and then can empower a lot of the small to medium like businesses as an example. Right? So there are a lot you can do if you think beyond the large language model obvious application like coding. So that's the area I'm kind of interested in.
Something that you learned outside of tech that made you better at your job?
Yeah, I'm big believer of the multidisciplinary perspective. If you actually have diverse experience, also if you are working in diverse team, I think you can do better and actually make much better kind of product innovations. In my background, also that really helped me a lot is that I have done many of different things. I used to be academic and the industry. I actually can understand both sides. As an example, also I used to be engineer and social scientist, computational social scientist, so I can connect both sides. They are actually thinking in very different way, and also different industries, right? If you are working in retail industry, they think in such a way. If I work in tech industry, if I work in financial industry, people are having some kind of different norm and different culture and different way to think. So having some diverse experience really help to connect the dot and then actually allow it to do more than the sum of the part. So that's where the magic happens.
Any final thoughts for the audience on large language models, AI?
I think we are living in very exciting kind of time. Also, it's little stressful and uncertain because too many things are changing. There are too many things happening. So information overload. But that said, it could be in some sense fair game. This is quite new. So everyone has to start from the same kind of starting line, right? So if you are actively learning and actively applying this to your business or for your research, I think there are a lot of opportunity for you to open, right? Or as an example, if you are adopting this technology and think about how you solve the business problem with certain kind of competitive advantage in terms of data or business domain knowledge, you might be able to have really strong startup with even with very lean team, maybe 4 to 5% instead of 100%, because AI will enable you to do more with the small number of people with the AI as another helping hand. So in a way, it's like 4 plus maybe 95 agent. So that will be very different kind of startup compared to the previous startup, right? So it open up a lot of opportunity for you to have your entrepreneurship or your own business.
Really enjoyed the conversation. Thanks so much for coming on.
Thank you.